This is Zoom for Monday, May 4th. As always, hope all is well with you and your families. This is construction surveying Zoom, forgot to mention that. And I think the thing to talk about first is to jump right into the fact that a week from tonight will give you the second hourly exam. And then that's going to be it for this course, other than the hands-on laboratory work that we'll do whenever we bring you back. And I don't have anything to report on that. I'm pretty much out of the loop. I've heard a couple of alternatives, but I don't really want to share anything until it's got to be approved by SUNY. So, but the exam is, again, a week from tonight. We'll start it at 6 p.m. instead of 7. I'll still give you that 4-hour window. I'm not convinced that it's the best idea, but, you know, it's just an odd, the whole thing is a unique situation. Let's leave it at that. So here's a list. I'm going to put this on Vanco eventually. More Philly rod readings, EDM component identification. I'm going to use the Nikon D50 model. It's in one of your handouts. So you got to go through there and look for the Nikon D50 model. A big part of it is the EDM geometry, which I graded the homeworks, I believe, last night. We'll go over that. That was the last page of the EDM data sheet, the geometry, if you will, height of instrument, instrument height, looking uphill, looking downhill, and so on. Coordinate geometry. There's going to be a good amount, quite a bit amount of coordinate geometry on the exam. Let's face it, it's all open book, right? You can use the Excel. The equations will be given to you. But hey, if you got the Excel and you know how to use it, and you know that you have to treat N1E1 as the equipment, the EDM set up over the control point. So that's going to be on. A little more radial layout, angles and distances that we've talked about. Just so have yourself a trig. Actually, it can be programmable now. I'm not going to be there. A function calculator. I guess there's a way for me to watch you take a test. That's a little too 1984-ish for me. I don't know if you ever heard of that book. I'm not going to do it. And but I got the Russians and the FBI all ready to spy on you. Whoops, shouldn't have said that, but just a little joke. Going to do some more pipe slopes. That was a project from last year. And so you're going to have to know how to figure out the inverts, if you will. Invert out, invert in, which is the difference between the two is a change in elevation divided by the horizontal distance. We may get into a little bit of profiles and cross sections. I might give you a profile and ask for data from that profile. And then building layout, we're going to throw a couple of examples at you. And you know, how do you lay things out? In other words, if you were going into that interview for a surveying layout job in the construction industry, we're going to give you a drawing that you've never seen before, and you're going to give us an idea on how to lay things out. So that's going to be a week from tonight. Like I said, we'll do a little bit of review tonight, and really just go over your go over the Zoom YouTubes. That's probably the best way to study. Just look at the homework, because that's where I'm going to be. That's what I'm going to be basing it on. So again, I'll post this to Vanco after the lecture tonight. Now, what projects are we going to do when we return? And we're going to do a layout / coordinate geometry project. And that's going to be the tank farm. And there is a part on the, or there's a section or a portion of the campus, what we call the lower campus, that really has a layout very similar to the steam plant project that I worked on in Boston. So if you kind of get a feel for the, can you see my Google Earth? Okay, there's the soccer field, wall complex and everything. Golf course right here. And so this is the entrance to the golf course, the new clubhouse. So this building right here, along with the roadway, lays very, very much similar. I don't know if that grammar's right. Sorry about that. It is very close in layout to that steam plant. So what we're going to do is we're going to, or you're going to, I don't do a damn thing. I'm just going to sit there and watch you. But what we're going to do, and here's the old Bing bird's eye view, which is no longer accessible, which is very sad. But here's the part of the old dairy barn. It's been converted into an auto lab. And very similar, what we're going to do is take the column lines of the steam plant at Boston, and we're going to show you how to lay out a brand new facility based on an old one with column lines. It's quite a unique little setup that they've done. And you know, the pump house that I showed you pictures of the mock-ups that actually you will do in heavy civil. The pump house is out here in the cornfield along with the two above ground tanks, and should work out pretty good. It's quite an extensive lab, but it's I like it. I've always enjoyed doing this one. So that's going to be one of them. And then, you know, you're going to have to figure out, and there's no work to do until you get here, but it's very similar to what you did with coordinate geometry in Smith Hall. Okay. So we're going to give you, each group has a different N1, E1. And again, what's critical? N1, E1 is always where the EDM is set up. That's the control point where the EDM is set up over. Okay. So that's going to be the entirely hands-on. We'll do some, I'll have my laptop out there, so we'll be able to use the Excel for the, so I got to get this little guy out of the way. So we're going to use the Excel that we talked about, right? And again, get yourself familiar with that for the exam. So that's the first phase of the hands-on of you running the equipment for quite a few hours, just getting familiar with the geometry that we've been studying in theory online. Frankly, I can't wait to get to that that hands-on part. So I do appreciate your efforts these past few weeks, and I hope never to do it again. So what else are we going to do? The other part that we're going to do is we're going to deal, you're going to generate a topographic survey of an area around the wall complex. And depending on how much time we're allowed for the hands-on, we're going to play around with some sidewalk designs. And let me let me go over that here. So these are all going to be, these handouts are all going to be given to you. So there's really no work to do between now and then. So here's the, actually this is a drone. Student had a drone, went out and was nice enough to take some good drone shots. Okay. And Smith Hall, God, I wish I was there. Actually, we would be on a Monday night. We would be just starting lecture in the pit. I got to stop that. I'll stop. So the wall complex is the maintenance facility, if you will. The offices for the folks who run the maintenance. And you probably notice that here's the sidewalk that basically ends. And so what students do is they walk through the parking lot, or they walk along here on the grass, go across here, and then walk in the road. And then eventually the sidewalk, they meet up with a sidewalk here that then goes to the parking lot, and then of course does the old loop around campus. And as you all know, it's not just you students, but it's all of us. We fly around these curves like a bat out of hell. And when we are working out here, it's amazing. As we're taking shots on the road, we have to have a spotter just to slow these little down. So the sidewalk plan would be to connect, say, maybe put in a sidewalk right here. So you'd have like a little diagonal crosswalk, put a sidewalk in here. That's easy enough to do. Put a crosswalk across here. And this is the nasty pinch point. There's two issues here. This one right here, and this one, which is a storm drain. There's actually a storm drain here and a storm drain here. So that's an issue over here and over here. That's why we have the washout station behind Smith now. We used to just wash it out in the parking lot years ago, in case we're being eavesdropped on by the, I better stop with the political jokes. And then it would just kind of wash out right here because it just came right underneath the wall complex. So that's why now the students put in the washout station for masonry. So you're going to do a topographic survey, and we're going to break up into at least 3 groups. And say group 1 would be this area, probably here. This is very easy to put in a sidewalk. We really don't need topo out there. So we would probably start right about here and maybe catch this catch basin right here so we can show where and also there's a light pole, a couple of light poles, and get a feel for, how the sidewalk's going to start in this little island right here. So area 1 would kind of go from the corner of the wall complex and do topo on here. And then second group would do this area 2, pretty much from the corner of wall right here to the corner of the wall complex right here. So they would topo all of this area right here. And then area 3 is from this corner of wall. We really don't need this over in here. So from here, maybe take a couple of shots on the building over in here, just so we can locate the building. And then pretty much run a path down to, say, that big pine tree, where we're going to tie into the existing sidewalk. So what you're going to do is you're going to shoot all man-made features, if you will, wall complex, this drainage ditch right here, the edges of the road, okay, the parking lot, and then we'll show a little bit of the drop off over in here, because when you're going to generate cross sections on Civil 3D, you'll be able to visualize the, from the, say, the new sidewalk to the drainage ditch, road, parking, and then, like I said, drops over the side. Now, that diagonal parking was not always there. So we'll give you a little history. And that means I'm going to go to Vanco. And where the hell is it here? Actually, let me just see where I'm at. Okay, let's go back to docs. Let's go back to projects. Yeah, these are some photos. There's your pinch point that we were talking about, right? So, you know, how are you going to put that sidewalk in there? That's going to be quite a unique little construction job right there. That's looking the opposite way. There's one of the culverts that we have to deal with. Smith Hall parking lot over here. And then here's the other, there's a little retaining wall. So that's going to be a cool little man-made feature that you're going to take data shots on and see how those contours react at a retaining wall. And again, here's the other drain pipe outlet, if you will, into the drainage ditch. And then the existing sidewalk over here with that big pine tree that we were talking about. And well, I thought I had a pic. Oh, here it is. Yeah, this is before the diagonal parking. So if you go back to the Word doc, right, all this diagonal parking was constructed, I believe, in 2007. So what they did, this is about where the new curb, the curb is. And so they created that diagonal just because of all the parking issues that we have at Delhi. It's too bad they didn't put a sidewalk in there while they were doing it, but it is what it is. So that's kind of a little history behind it. And let's zoom in out of that. So we're going to break up into, like I said, 3 groups. Not sure what the maximum number in each lab is going to be, depending on social distancing. It really depends on when we get together. And like I said, we'll be eating a lot of pizza while we're working. So we'll pull some long hours, but we'll keep you fed. That's a promise. And so each group is going to be assigned kind of a number system. Like group 1 is, all your shots will be 1,000 till 1,200, group 2, 1,200, and so on. This is based on the old lab schedule, and that'll be changed. So we're gonna, like I said, we're gonna shoot roads, parking lots, drainage ditches, buildings, sidewalks, utilities, the terrain, the lay of the land. And so you'll probably get a good 3 hours of field work for each group, taking data And we're going to rotate you constantly so that you're taking data. Some are actually running the total station. Others are writing the data down. And once you do that, then we're going to give you a file, and you're going to download that into Civil 3D. And then we'll also have you plot your own data. I think we have you plot maybe 10 points by hand of your own data. I think we say have some shots on the building, the 2 drain inlets, the control points, excuse me, and then we give you the entire shot data list. And so you'll have 2 CAD drawings, and you're going to overlay your shots with the master copy, if you will, from Civil 3D, and just see how accurate your shots were. But that way we're able to, you know, jump right into a full-blown analysis using Civil 3D. So for the tank farm that we just showed you down at the lower campus, that's all field work. This is a combination of field work and Civil 3D in the computer lab. So I think it's a good project for you. It's right next to Smith Hall. We don't have to travel very far. If there's ever an issue, you get to go right out there and take a look at things. Now this one, let's see. This will also be using coordinate geometry. It has coordinate geometry right now, but if you'll notice on this one, and this is the control point number 2, delta 2. X and Y really should be written as northing and easting, but the Y is the easting, right? The Y-axis is the north-south line. And if you remember, Mr. V was teaching us that you go with assumed northing and easting if you don't have GPS information. That reminds me, we might be able to get my my friend Kevin, the surveyor, to come in with his robotic total station and his GPS and do a little show and tell for us as well. That's always a good time. So if you look at this, typically we go with north 5,000, east 10,000. So don't forget, position Y is the northing, position X is the easting. That would be a really good test question. Okay, chances are you're going to see that again. So the northing and easting, if we're set up on delta 1, there is its northing and easting, and we shoot over to delta 2, and we know that northing and easting, that should give us the distance between the two and the angle off of the off either looking north for the back sight or looking south for the back sight. So you want to get familiar, and we've gone over this, you want to look through the PowerPoint for the Smith Hall layout, the garage layout, that will help you with the angles. In other words, what quadrant? Am I in quadrant 1? In quadrant 2, the angles that are generated are using this line. If the EDM is right here, they're using the north line of sight as your back sight. So anything that's in quadrant 1 or 2, it's going to be, if it's in quadrant 1, the angle is measured here. If it's in quadrant 2, it's measured counterclockwise off the south line, or off the north line. If you're in quadrant 3 or 4, then your back sight is again, N1, E1 is right here. And you are looking due south, that is your backside. Doesn't have to be, but that gets into more complex stuff, which the book does, which we just don't have time for. So I did a wall sidewalk. There was my, these two numbers right here, 4934 and 9869. Right, 4934, 9869. That was our N1, E1. And of course, the 5000, North 5010, sorry, North 5000, East 10,000 is the point that we want. So let's show this so it's right up there for you. So that's our N1, E1 at delta 1. Delta 2 is this. There's the angle, 63.26.6. And the distance, 146.21. So I figured I'd just show you where did that little sucker go? Here it is. So here is the topo that you're going to be generating. These big circles are the canopy of the trees. Okay, that's why you see that. And so here's delta 1 right there. And let's do an analyze. And this little bugger's always in the way, so let's get that out of the way. And so let's go from here over to delta 2. (146.26). So again, that's the beauty of coordinate geometry. We can design that sidewalk. Right? Here's the road. Here's the roadside ditch. So if the sidewalk is going through here, maybe we want the sidewalk over here. All right? Either way, we can, as you design it, you can get coordinates for it, northing and easting, and then you can do a radial layout set up on delta 1 and shoot every part of that sidewalk project that is within view of delta 1. So again, a very, very powerful tool. So that's what you're going to be generating this. Yours should look very similar to this. And then we'll show you some profiles and cross sections. Remember the pinch point on the building? Right, so we wanted to shoot the side of the building. We wanted to shoot the drainage ditch, the side of the road, and then we stationed that 1 plus 10 plus 1 plus 10.48. Which I think is this one right here. Right, so there's the edge of the building. And again, it dropped right off. And here is that center line of the drainage ditch, and then the center line of the road. So we're going to get back into doing some cross sections. Okay, let me go back to my list. So now what we'll do a little bit of EDM geometry. And this is what I graded last night. And let's see, I got to go to Vanco. And let's see, answer key. Okay, so this was page 4 of the, this damn thing isn't it? Page 4 of the handout. And what I would recommend to you is go back to this PDF that is on Venko and really get familiar with these photographs, because your sketches, I would dare say over half, were nowhere near what the sketch looks like that we've been working on. Okay, so this little sketch right here is kind of a sketch of what you're seeing right here. So let's see, let's go back to the PDF. Okay. First of all, this has got to be 0. This should have been written as 0, right? Because your back sight is delta 2. And this had no data in it, which means that it's a blunder. I think maybe 2 people got that right. So we had talked about that earlier. If you forget some of the data, if you forget to write it down, and it does happen. It's happened to me. It's happened before. It'll happen again to me. That data point is basically worthless. You got to have all of the data: horizontal distance, horizontal angle, vertical distance, elevation. That's typically done by the software. And you need this description. You can get away maybe without a description, but it does make things a little tougher. So that's what we wanted to see on this. Okay, that's what we wanted to see on this. Now, the next thing, and the first thing is, you're always going to establish HI. You're going to have a problem almost identical to this on the exam. Okay, and here's the sketch that I was looking for. And the HI is just an imaginary plane through the center pivot on that telescope. So in a way, you can use your total station for checking elevations. Okay. This is the prism height. And if you look at the only place it says HP, which is high prism, in other words, the prism was extended, right? This prism has been extended. You can see the difference between the two right here and right here. So you want to show these, then you've got your V, your vertical distance. Over here, you've got a vertical distance. This is always going to be positive because I'm looking uphill. Here, the vertical distance is always going to be negative. It is the vertical distance from the reflecting prism, the glass mirror, to the imaginary height of instrument, which is an imaginary plane through the center pivot of the telescope on the total station. Now, when you look, the first thing you're going to do is look at the benchmark. When it's negative, that means that it's downhill. You're looking downhill. If that were positive, and some of the problems showed that, right? So our V, the readout on the total station, shows as a negative, which means I'm looking downhill at that benchmark. That's the first thing you got to do. because that's going to dictate how you calculate the HI. You always start from the benchmark. Here, we went over this before. The benchmark was negative. The vertical distance was negative. The second one, the vertical distance was positive. That means I was looking up at the benchmark. Okay. Sometimes what I do is I establish two benchmarks, and then when I'm out in the field, I calculate, I go with the elevation of one benchmark, take a shot on the other, and see if the math works out. And I try to do that every time I go out. It minimizes making some blunders. So here, because it's positive, you're looking uphill at the benchmark. Benchmark, you're still looking uphill. We went through this one. And here you're looking downhill. So because I'm looking downhill, the way to calculate the HI is it's got to be the benchmark plus the prism height, and it does not say HP, so I use the regular prism height. So that gets me from a point of known elevation, the benchmark, plus the prism, plus whatever that reading is. Now, you could say, well, that's a negative V. I know that, but this is just to establish HI. So this is why I wanted you to put in a sketch. So if you go up here, HI, whoop, there's the benchmark, plus the prism height, plus the vertical distance. And a lot of you subtracted that. And that's why your data was wrong. So it's 1089.71 plus 5.91, which is P, right there, plus V. And V, you could say that that's plus an absolute value, but if you draw the sketch, it just makes sense. Right? You don't throw in that negative. This is just for establishing HI. And so that is 1101.27. Now then I'm going to ask you, what's the elevation at delta 1? Because that's where the instrument is. And that's known as the IH, the instrument height. This is not a great sketch right here, but the line is from the center pivot point to the top of the control point. That's IH, instrument height. Now, sometimes you will work for surveyors who interchange HI with IH. You just got to get used to their use of the terms. So if you wanted the elevation of that control point, it's whatever the HI is, which you now have. And how do you get the IH? How did I get that? You literally measure from the center of the axis of the telescope to the top of the control point. So the IH is a vertical distance. The HI is an elevation. Okay, once you do that, then every other elevation of subsequent data points is based on your HI. It's like running a laser level in the lab. Once you backsight on that benchmark, at the backsight to your elevation, everything else is in relation to the HI. So now if you go to this one, this is a vertical distance of 7.61. It's positive, which means what? I'm looking uphill. Okay. So now, this is the data point that I want, say delta 2. Here's another one looking uphill, so it could be the toe of slope, right? The land might go like this, so So this one is the HI plus V minus P, or HP if it's got HP written right next to it. This one does not, so it's HI, which is 1101.27, plus V, which is 7.61, minus the prism height, 5.19. 5.19 gives you an elevation of 1103.69. 12 slope, it's also positive. And because that vertical distance is positive, I'm looking uphill, I can use the same sketch. The only difference is now I got a high prism. So again, I go with HI plus whatever V is minus the height of the prism. So I got the HI, 1101.27, plus this 11.45. Oh shit, I did it wrong. Oh no, I didn't, sorry. Sorry about that, didn't mean to swear either, shouldn't have said that. So V is 11.45, right? HP is 9.19. So it's HI plus 11.45 minus the prism height, but it's high prism. So it's minus 9.19 for an elevation at that point of 1103.53. Now you've got the last shot. You could say, well, why are you doing it? Because it's a blunder because you didn't write the horizontal angle. You're right. Well, let's do the math anyway. So, because this is negative, I'm now looking downhill. I don't know that elevation, but I do know the HI. So it's HI minus V. That's why it's got a minus sign. It's not minus a minus. It's just HI, subtract that vertical distance, subtract that prism height. 1101.27 minus 5.07 minus 5.19. Okay, minus 5.19. And that gives you 1091.01. So this is what your sketch should look like, okay, on problems like that. Any questions on this? Is the sketch making sense? I hope. Always take the sketch and analyze it versus these photographs. You're either moving up or you're moving down in elevation using a benchmark, height of instrument, which is an elevation. The rod reading is really the prism, right? And then the vertical distance. So you'll see a good amount of that on the test next week. I think that was about it. So I'm getting close to being done with surveying. Let me look at the rest of this is all the soils. Oh, this is a CAD drawing of that lower campus that we're going to give you. You're not going to have to do any. That's for the tank farm coordinate geometry project. We're gonna mark this up, get the contours in, and get you some copies of this. This will be pretty cool. We're going to try to do a little bit of road layout on that project, little route surveying, and basically it's used on the old design at the steam plant, they have what's known as point of intersection, point of tangency, and they give coordinates, northing and easting for that. So we're going to be able to lay out the road, which extended out. So if the tank farm's out in here, this roadway extended out to the pump house. So we'll get into a little bit of route surveying. Okay. And like I said, I do apologize to one of you. You sent me an email about looking for work. I think it was in northern Jersey. So the idea I had last week would be to have you Google material testing companies, whether it's northern Jersey or wherever, and see if they're hiring technicians to test concrete. Tell them that you've had ACI, American Concrete Institute, training on concrete testing. You're also going to be getting some soil testing background, and you've also got a fair amount of knowledge on surveying. So I would look up local surveyors. There are a lot of openings for surveyors. There's not a lot of surveyors, at least up here. That may be different in the metro areas, but that's what I would do. Google the surveying companies. Even the engineering design companies, because sometimes they have their own survey crew. That's who I actually worked for back in 1979 and 1980. Okay. So I've got that. We went over that. Surveying exam a week from tonight. And to go over again, I'll put this to Vanco. Philly rod readings, EDM component, identification of the actual total station, the EDM geometry that we just reviewed, and coordinate geometry, radial layout, pipe slopes, building layout. Basically, this is a geometry course. Okay. Do you have any questions? Or are you all asleep? Don't answer that question. Well, you couldn't if you're asleep. So I'm damn near asleep. I know that. So we're going to start again. Any questions on surveying? You're okay with a test a week from tonight? Now, one thing we could do, I doubt I would do it, but I could give you a third exam when you come back. I probably will not do that. I may give you some quizzes to help you get some points. There will be a lot of potential points to gain when you come back for those hands-on activities, both in the field and with Civil 3D. So what I'll do at the end of this test, and I still have some notebook, some field book corrections to look at. I put them into a separate folder, so I haven't lost them. I haven't forgotten about you. What I will do is after we give the test a week from tonight, and it's all graded, and I get everything entered in my Excel, I'll send you your final average on a point basis. Because I think for this and heavy civil, I'll be giving you a grade of what they call IP, which is in progress. I don't think they're going to have me give you a letter grade, but I will give you the number average. You will be able to raise those averages when you come back. So it's not just going out there and standing around. You're going to be generating data. You're going to be laying out buildings, coming up with a sidewalk design. We're going to throw a lot of points your way.
When are you going to have a definite on when we're going to be coming back for those labs? Just because, like, I have summer work lined up just so I can let them know what time I'm going to be having to say I'm out.
I don't know. As soon as I hear, you'll probably hear before I will, because they'll send it out as an email, or we'll probably hear about the same time. I don't know. because it's all got to be cleared through SUNY. And it all depends on, on these directives, for lack of a better word. I know what I would like to do. I mean, I know some of you, are moving and I would work with you, but my own thing is I'd rather bring you back in August. That way you only got to move once. You're back here anyway. And just get it done. Wouldn't bother me in the least. Work 10 hours a day for a week and a half, get it done between this and heavy civil. Just keep rotating you from all the mock-ups. So, but that's what I'll do. You'll know exactly what your point average is by the 18th. Okay. You'll have it for this course even sooner, but that's when I have to post the averages. Okay. So we're going to end the Zoom surveying Monday night, May 4th lecture. And what I can do is I can